Thanks, everyone. Hi. Hope you had a good start to the fair so far. It's good being back. Yes, like explained, I'm Leo. I'm a chemical engineer, and I work in the field of textile recycling, specifically polyester recycling. And today I can share a bit about our challenges when it comes to textile recycling and how we work on solutions to close the loop for polyester. All right. So PET in general, which is the polymer that's also called polyester, has a global production volume of about 120 million tons each year. That calculates down to nearly 4 tons a second. And 2/3 of this material end up in textile applications, and about 1/3 goes into packaging applications. And while the production and manufacturing of polyester is super scaled and optimized, the end-of-life system for the various applications where the polyester is used is increasingly overwhelmed by the amount of waste that is generated through this material. In the field of textiles specifically, it even goes this far that the waste that is generated is not even targeted specifically to recycle polyester, but instead the focus is mainly on retrieving still reusable pieces out of the waste stream that can be sold on a second-hand market, and everything that is not reusable anymore and still contains a lot of polyester doesn't really have a solution today. So where does polyester come from? Basically, we have two main sources. First being virgin polyester, and second being recycled polyester. And virgin basically starts its supply chain from oil, and out of the oil, over a sequence of petrochemical production steps, basic chemicals are produced called monomers. In the space of polyester production, that's terephthalic acid, PTA, and monoethylene glycol, MEG. And those two basic chemicals can be transformed into a polymer in a step called polymerization. So it's a chemical reaction. And then we have the polymer PET, which has the ability to melt when we increase the temperature. And by melting this material, it can be transformed either into a fiber or also into something like beverage bottles we all know and use. And specifically, these bottles are disposed of after the use case and then serve as an input material for a process called mechanical recycling, which leverages on the ability to melt the material and bring it into a new form. So it can result into a new bottle, but it can also be processed into a recycled polyester. And on this system that is available today, basically two issues are here when it comes to circularity. First of all, is that for the sake of increasing the recycled polyester content, we cannot just produce more bottles that can be turned into a fiber, but instead we need solutions that can handle textile waste. And secondly, to really increase the recycled content and the circularity for a material, also the virgin part of the supply chain needs to be integrated into the circular system, because when the virgin plants are disattached from the circular system, then this virgin component will always be very big because these plants will run and they should be included in the circular system. So why does bottle recycling alone not solve mechanical complex waste? So looking at these pictures, it appears to be quite straightforward that we can see that the bottles on the left-hand side is a fairly clean type of waste that can be collected separately from other types of waste. And as soon as it's collected, not much work needs to be done in order to bring it into a new product. Compare this to other packaging feedstock, for example, like trays or films, which are also very prevalent in the market and also contain a lot of polyester. The challenge already becomes more greater, because the material is blended and mixed with other materials, and it also contains a lot of colors. And that's why also the collection of these other food containers like trays and films is a lot less compared to bottles. We're now looking at textiles, where about 7 million tons of textile waste is only generated in the EU. It becomes even more challenging because within the 7 million tons, it's not all polyester, but polyester is only part of it. And to actually sort out this textile waste for the sake of recycling, basically all of the components of this waste need to have a solution. Otherwise, one recycler, like a polyester recycler, also needs to pay for the sorting of all the other materials in order to clean the actual waste from the side fractions. So it's more work need to be done on textile sorting and collection. And then once the material is sorted, it also is not yet ready for recycling because the textiles need to be pre-processed mechanically. They need to be reduced in size, and hard parts like buttons or zippers need to be removed to make it possible for recycling. So clearly there's a gap for circularity, and that mainly comes down first to the lack of infrastructure from sorting and collection, but also different recycling technologies that can take care of different fiber types. And because this is not established and scaled at volumes, also the system in end of life lacks performance. And while the end of life in recycling for textiles is not established and lacking performance still, it's already benchmarked against cost from a virgin system that has been scaled and optimized for decades. So clearly there needs to be a transition which includes these kind of aspects in the way to a circularity. But it's not all bad news. So there also is clearly a momentum for circularity, and that's mainly due to policy acts being implemented that will address certain issues with this topic. First of all, it's the availability of feedstock for recycling technology that's more enabled and more facilitated. And also the offtake of recycling technologies that is mandated through recycled content that will help to sell recycled products into a market at the start of a transition. And with the amounts of waste that are generated, obviously the pictures are coming up, and consumers are becoming more and more aware that this is a problem and something needs to change here. And the good thing is that also technology, both on the sorting side but also on the recycling side, is emerging and is developing, has been over the last 10 years, let's say, and is now ready and on the verge of actually stepping into the industrial application. And also we as Meta provide a solution that can recycle complex waste like textile waste and bring it into a form where it can be reused very seamlessly by the existing supply chains. So again, let's take a look at the current system and the linear system the polyester is in. So like I said, it starts with the fossil resources. It goes over the monomers, PTA, terephthalic acid, and ethylene glycol. And those are used to produce the polymer PET, which ends up, like I said, in packaging and textile applications, where only the bottle part of that has a mechanical recycling, and the major part of this types of product do not have a recycling. And that means that sooner or later, every molecule of PET that is produced at the start of the supply chain ends up in the waste that today is either incinerated, landfilled, or leaked into the environment. Because there are no recycling technologies that can uplift the quality again to something better, higher quality, for the circle to start again. And that's exactly where a modern recycling technology needs to work at. It's the ability to first include complex waste as a feedstock, so waste like textile waste, and transform it into products that have a high value and that can be directly used by the existing supply chain. Because recycled products always or can face an issue where a lower quality and the lower performance of a recycled product will really be a block for actually scaling this material. Therefore, recycling technology has to have a high quality output that can seamlessly be integrated into the supply chain. And with a solution like this, also one other thing that I addressed earlier is already met, because the recovery of recycled monomers, as in this case, enables today's virgin plants to produce recycled material tomorrow. Today, only virgin material is available, so the monomers are only available from fossil resources. But through this kind of process, the virgin capabilities that are already in place and that are producing these 120 million tons will be enabled to also produce recycled material. And that's actually like leveraging much more the ability to scale recycled content for polyester. Process works like this, can be divided in 3 different sections. So first of all, it's a reaction called depolymerization. Then we have a middle part, which is taking care of the purification. And then we have a part that's directed to the recovery of specific products. And the focus on the waste for our technology is about 80% of polyester and 20% anything, although anything can be definitely more complex or easy depending on the chemistry and on the composition. And as long as there's 80% polyester in the waste, it will go into the reaction, the depolymerization, and basically the reaction will do one main thing. It will break down the polymer structure to the monomeric level, and by doing so, the monomers are turning into a water-soluble condition. So by breaking down the polymer structure, these valuable monomer components are water-soluble and therefore can be separated from all the other fiber types like cotton or nylon or elastane that will not become water soluble through this process. So it's just a simple filtration that removes the blended fiber types. And then we still have a solution that contains colors and other water soluble components, and this needs to be purified also with dedicated purification systems. And then in the end, after purification, the 2 products, terephthalic acid and ethylene glycol, can be recovered with specific processes to achieve the final quality that's needed to be drop-in ready into existing polymerization plants. And with this type of process, the monomer that's coming out at the end doesn't really remember if it used to be a textile or if it used to be a carpet or packaging, but it's just a chemical that's used to be in the first place before all the production actually happened. So for such a technology to actually be viable for scaling, few things are very important. First of all is that the reaction itself, the chemical reaction, goes very quick. In our case, that's about 95% of conversion within 1 minute, and it's a continuous process. And in the end, drop-in monomers that can seamlessly be integrated. So just flexible supply of recycled monomers wherever needed, and also for which sector it's necessary to include those. And then the whole process is built on off-the-shelf standard equipment that has already been scaled and shown in the industry and other industries. So there's a lot of knowledge about every part of this process already available, which de-risks obviously for scaling. And with a system like this, we always like to think bigger than it is today. Because today, the discussion is tending to be textile to textile recycling, packaging to packaging recycling, and every sector is trying to find their own solutions. But polyester used to be monomers in any application at the start. And when recycling really needs volumes of material that can be recycled, and processes are able to recover monomers no matter what kind of product it is, then we should only differentiate between 2 things. First, is the material mechanically recyclable? If it's mechanically recyclable, then it should be mechanically recycled. And if it's not, it should be chemically recycled in that way, and then it could be supplied into any other application again, and it should be counted as recycled content, because otherwise the materials are still incinerated. So let's think bigger on this, not only on textile to textile or packaging to packaging. So where are we today? We operate a pilot plant in an R&D center here in Germany, attached to a lab. So this is used for process optimization and feedstock approval. And based on that, we were able to secure 30 million of funding from the state of North Rhine-Westphalia, also here in Germany, and an investment from Bestseller, which enable our next steps into scaling up the technology. And that will also be done here in Germany. So we will now build our first industrial plant with a feedstock capacity of 11,000 tons a year, which will showcase supply chain integration on an industrial level, which will also be the first step into commercialization and basically providing a platform to actually start off this discussion about how do we handle waste more efficiently and how does the integration into existing supply chains can actually work. Because one thing is clear, 11,000 tons is not enough for the waste that it's generated. And it's also not enough to meaningfully increase the recycled content in polyester. But technology alone cannot scale because waste needs to be brought to the plant. It needs to be the logistic aspect for sure. It needs to be sorted. It needs to be prepared. So the technology definitely is dependent on an ecosystem that's working in order to be further scaled. And that's where we want to be one part of, and want to help create momentum to actually bring this into a new system. Yeah, and that's basically how we're seeing our impact right now. It's creating momentum across the supply chain, mainly on the end-of-life sector, to get the materials ready for recycling, to find out how it's possible, to find out how the performance can be scaled for further plants, and build on this for the future to even increase capacity of recycling further. And yeah, with that, I like to thank you for the attention. Look forward to questions in case there are any. And yeah, thanks all.
Do we have any questions from the audience? Here we go. Let me grab a microphone. Thank you.
Hi, thank you very much for your presentation. My name is Joanna Riedel. I am from the Hohenstein Institute, and I have a question about the separation process after you have dissolved the textiles into fibers. So how does the separation work? Like, do you use osmosis filters or whatever to take out the fibers and the metal residues, or like how do you get the particles? Like, what form are the particles in then? Is it just like a sludge that you can drain, or how does it work?
Yeah, the filtration is a part that can be very different from feedstock to feedstock because the side components always differentiate. So we need to find a solution that tackles many of the variety that it's coming. And therefore, yeah, it's a mechanical task where there are solutions that can be very flexible when it comes to filtration. Metals are not contained in there anymore because metals will be removed during the pre-processing of textiles. There we can make sure that no metals enter the process, and then it's just a standard technology for filtration that removes the blended types.
Thank you. So we hear again the importance of the pre-treatment and the sorting and the sorters and recyclers work.
Yes.
Any other questions?
Thank you. I wanted to ask, where is the borderline of your process with coatings like PU coatings, TPU coatings?
So, like I said, 80-20, 20% anything. And the case for polyurethanes, same as for elastane, for example, is that the process can take these materials and we are able to recover the monomers at the required quality level, for sure. But the process has then other types of waste streams that we need to get rid of because we need to remove more complex waste out of our own process, which increases the cost to recycle such a material. And while it's possible on a technical level, it's again then a question on how the business case will evolve and how also something like EQ modulation will evolve about, and market dynamics will evolve around some more complex compositions containing TPU. So I think that's also one of the major questions to be addressed down the line. when really a broad variety of such feedstocks need to be recycled, because it also needs to. So circular economy has two words. It's circular, but it also has economy, and it needs to be economical in a way, and we will see. I guess.
Thank you. Anyone else? Okay. Before we wrap up, where can people find you or get in touch with you?
So I think I had some contact data here, but just reach out to me afterwards. I will be here around, and find me on LinkedIn. I don't know. I think there will be many ways.
Okay. Thank you very much.
Good.